Hey everyone, welcome back. This is part 2 of the Denver Electric Vehicle Council webinar with Aptera CTO Nathan Armstrong. If you missed part 1, you could watch it by clicking on the link right here, or you can click on the link in the description below. I'm going to keep this intro very short, so please like and subscribe to the channel. We appreciate your support. Don't forget to visit our Patreon page at patreon.com/Aptera Reboot. You could also support us via our merch store at apterareboot.com. As I mentioned in part 1, there's a lot of new information in this webinar. Hope you enjoy it, and I'll see you after the show. Let's go.
Hey, I was wondering, when you go to start production, are you going to go in reservation order, or according to options, go with all-wheel drive first, or biggest battery first, or?
Oh, I believe the celebrities go first. I'm just kidding. No, we just go order received. We're just gonna go as fast as we can to get them out. So, yeah. There's a back wheel bounce up and down to a lot of rear rotation, and front wheels are turning in opposite directions. The rear wheel is just a regular swing arm. We looked at doing fancy things on the rear, but really the weight penalty wasn't worth it for us. Licensing problem because it's motorcycle? No, actually, Nebraska is the only state right now that has an issue with this, and they're changing their laws right now. So every other state is no problem registering as a motorcycle. And yes, there's no paint; it's just wrap.
Well, I mean, you're in Canada, so how about Quebec and Ontario and all that? Just curious.
Canada, man, I tell you, they're so far behind. Federally, it's legal. Federally, it's legal anywhere in the country. Provincially is where they make up their own rules and they have some issues. But yeah. That's Canada for you. But yeah, I saw a Harley Davidson trike on the road here the other day. So if a Harley Davidson trike is allowed to drive on the road, you know what I mean? Anyway, just saying. Any plans to make it autonomous self-driving? Not at this point, but like I was saying earlier, that whole technology suite is becoming much more accessible now and much easier, right? So 5 years from now, it's just going to be a plug and play kind of a thing. So, yeah.
I think you asked, you must have already said this earlier on. I joined you about 10 minutes late, so I apologize to the group if this is repetitive. When are the cars going to be up for sale?
Limited numbers beginning next year and then full production by June.
What does limited number mean, do you think?
Well, less than 10 in January, less than 50 in February, less than 100 in March, kind of thing, but those kind of numbers. And it's actually Monroe working with us and all that. So Sandy Monroe and his group are doing all the production planning for us, and all the plant layout and everything. And they're incredible. Like, these guys are absolutely incredible. And we've got kind of like I don't know if they call it a hybrid factory or what they're calling it, but the plant layout that they've done for us is not like any of the plant layout that we've seen. And it's a lot of human labor, right? Because the parts are light. Like we said, it's human focused. Which is really interesting, but yeah, it's all coming together. The production plans, the factory layouts, how it's all done, all the dunnage, all the cranes, everything like that is all coming together. And yeah, so there's a lot to do between now and then, but yeah, we hope to be getting the first cars out January. And Jay Leno might be first. I see that one. I don't know if he's going to get the first one, but I know we are working on another piece with him, like right now. So he's probably going to be involved at some point. And the off-road kit, there's a question here about that. So the off-road kit, so it'll be different wheel pants. If you are going off-road, you can just take the wheel pants off as well. They're only required as an on-road vehicle. And then we are looking at a height adjustable suspension. So if we can do it without a huge weight penalty, we'll do that. Because that gives us a lower ride height of speed as well. So that would give us another level of improvement. Batteries in the wheels. That's scary. Actually, the last one I saw recently was a massless battery that used the carbon fiber weave as the battery. I don't know if you guys saw the article, but they had basically like the weave of the carbon fiber, and one side was the cathode, one side was the anode, with the separator between them, and the whole shell became the battery essentially. And they were only 20% as efficient as a lithium battery now. But that means we could literally turn a whole car shell into a battery. Like that's really, really weird stuff. But probably not batteries in the wheels. Other questions we got. Yeah, the security one's good, right? With the phone-based keys instead of the key fob. Again, we've got lots of options there. Nice. There's some great questions in there. This is a really good group, eh?
Well, ask them.
I'm just looking through the list here. What do we got? I think I've answered most of these. CO replacement on the motors every 30,000 miles. Is that something, I haven't saw that one. Is that something a lot of folks talking about? CO replacements every 30,000 miles? That would be something we'd probably move away from because we can change that with different CO technology.
When will there be an opportunity to test drive?
I don't know. If you actually go down to San Diego now, I don't know, on the YouTube channel, there's a girl showed up there with like a little, like she's from England, she had like a little YouTube channel. And she showed up and said, hey, can I take a ride? And they took her for a ride. And she posted it, and it's fantastic. And it shows the acceleration actually, which is really good. So I think if you go down to San Diego, just knock on the door, you probably get to have a ride. They're pretty friendly down there, so. But it's crazy. If you go on the YouTube channel and check out that video, actually, you can see the acceleration. It's really remarkable. Like, those motors are going to be incredible. How flammable is the shell's composite material? It's not. We actually have flammability inhibitors in the composite resin itself. So it doesn't burn.
No, that is good to hear, because I mean, Ashburn, Virginia, we just saw a bolt catch on fire.
Yeah, I saw that one. The guy, one of the guy's garage, right? Yeah.
Yeah, right there. Ashburn is about 5 miles from me, so oof.
Yeah, that's scary. That's scary. Yeah, no, we've had a few.
They're doing a recall on the bolt right now for that, and I don't think they're finding too many batteries that need module replacements, at least from my experience with our bolt, what the guys at the shop said. But I don't know. Some of these guys seem a bit comical, so I don't know how much we can trust their diagnostic work.
Is that what it was? It was just a cell shorted out and go viral?
Yeah, apparently they had a batch out of Korea, that the batteries that were problematic, and so they recalled all the bolts that might have those, doing some kind of testing procedure and changing the software so that later on, if a problem develops, it'll let you know sooner rather than later. We notice the software change now. Whenever we get out of the car and anything's in the back seat, it tells us to check the back seat. So even though the guy at the service center said, no, we didn't change the software because you didn't need it, we know they did, which was actually part of the 11-page NHTSA brief on it.
Yeah, and apparently they didn't have the software update, the ones that had the fire.
We've been looking at some interesting forums in, guys doing home built batteries and that kind of stuff. And there's a bunch of people experimenting with a way to cut the nickel plates. And when you connect the cells together, you actually do like a little spiral where you connect the battery, and it becomes a little fuse. And if the battery ever happens, like anything happens, it just burns that it removes itself from the pack kind of thing. I think it's really clever. And we're experimenting with that, see if it works. Like but that's a cool idea. I like that kind of stuff. When will you add wings? I know, right? I know. I keep telling the guys, we've got the perfect platform here for a flying car. It's aerodynamic, it's lightweight, I don't think it's in the scope at the minute.
Range.
Will you build your own battery packs, or are they from a third party? We are building our own packs. We're using standard cells. But this is a crazy one. Like, if you had $1 million to invest in a battery company, right? Like right now, like where would you put your money? Right? Like, it's changing so quickly, and every 6 months there's a new technology. It doesn't quite make it to market, but it threatens to kind of change the whole industry again. So battery technology is a really weird one, right? Like, we have these lithium cells today; they're pretty good. 5 years from now, they're going to be way better, different chemistry. 10 years now, something different again. So we're trying to be kind of battery agnostic to a degree, and also the idea that you can upgrade your car or change the battery at any point to a different battery chemistry. It's just a controller, thing, so it's not a big deal. But yeah, no, the batteries are almost like, we try and keep them like separate from the conversation, right? I don't know if you guys saw in China now, there's a company that sells the battery separately from the vehicle. So that's something we've been talking about doing for years and never actually did. But from that perspective, you got a $40,000 car, $20,000 is the battery, right? So if you remove that from the sale price, maybe you buy the car, lease the battery kind of thing, you change the whole economics of the vehicle ownership. So there's a company in China doing that now. And as I said before, with batteries, it looks like they're going to start lasting way longer than the vehicles, which means you can amortize the cost of the battery over 3 vehicle lifetimes, right? So like where it's going to land on batteries right now, like no one has any idea, right? It's really a strange time to be in this industry, right? And of course, with the mineral resource issues and mining, all these mining stories coming out about lithium extraction and all the horrible stuff you see around that kind of stuff now, like we're going to start seeing more attention put, I think, to battery technology. And like, I think we're going to see some interesting alternatives coming out here pretty quickly, right? Especially on the solid state side of things. I think we're going to see some interesting breakthroughs.
Speaking of the solar panels, I assume that's thin film solar. I just was curious what type of cells and what the total wattage is.
Total wattage, I'm not sure. They're regular cells, like regular silicon cells. We found the highest efficiency ones we could, and that's what we're using. But they're just a monocrystalline cell, like you find in a solar cell. They do bend a little bit, which works in our favor. That's how we're able to do this. 700 watts.
Mr. Armstrong.
Oh yeah, that Japanese motorcycle manufacturer thing is interesting with the batteries. It's an interesting one though. You know, I don't know about that one. It's weird, right? Because so in our vehicle, you take out 4 bolts and the belly band comes off, and then the battery's right there. You got a bunch of bolts around the battery and it comes out, right? About 24%, yeah. So the battery is something that we could, and of course, as for the big battery, like if you just wanted a 200-mile range, your battery is literally like suitcase size, right? So, you know, that's something that you could get out fairly easy. So I don't know. Obviously, it wouldn't work for vehicle. Actually, what I have seen in India, have you guys seen how they standardize on the same thing, but like in the tuk-tuks? Those little kind of like little cargo vehicles have done the same thing, but they've kind of done it, they sort of did it accidentally, where somebody came up with a standard. Now it's kind of become this widespread thing. And it's similar to the thing they're doing in Japan, but bigger batteries. So like they're almost too big for one person to lift up. And of course, that's the issue you run into, is just being able to handle the batteries, because they get heavy real quick. But it's cool, that standard, I like that one. The interesting one about that one too is that when you put have you seen the rack that the battery goes into? I think there's a company in Europe doing this, where they have like on the street, they have like a big rack of batteries. You just go plug your battery in, take a new one out, put it in your vehicle, and off you go. That rack now becomes the center node of the microgrid. So that thing holding all those batteries becomes something that can actually power the local community. So it's a very interesting idea with swappable batteries, because you get to the point where you could kind of replace the grid with enough solar vehicles, right? So the resolution of the video camera, it's just normal. I don't think it's anything too crazy.
I'm curious about climate control, audio, and other accessories, and how those affect the range.
Yeah, no, it's an interesting one. So finding lightweight speakers, right, that kind of stuff has been a real challenge. But we, same on the HVAC too. And the HVAC is obviously a massive part of the power draw on an electric vehicle, right? And also from a weight perspective and a cost perspective. So we're coming into this at the right time now. 10 years ago, you try and find an HVAC unit for an electric vehicle, and they did not exist. If you go out to the market now and you want an HVAC for an electric vehicle, there's about 20 options. And they're all really good. And there's some made in Canada, some made in Europe, and some made in different places like that. So the cost is accessible now for like a regular kind of HVAC. So we just got like a standard HVAC system. We don't have a heat pump yet. We would like to do that, but we're kind of like Tesla in that respect, whereas one of those engineering challenges that's just kind of like too much from the first phase. So regular HVAC for the first car. Steve is a ridiculous audiophile. Like he's made his own speakers and all that kind of stuff. So we've got this insane 11 speaker system in the thing with subwoofers under the dashboard and speakers everywhere. Like it's incredible. But we're working with the company on lightweight speakers and getting the weight of the speakers out. Even the coils and everything, they're trying to make them lighter for us. heated seat or steering wheel. We've got prototypes where we've got heated and cooled seats, and that was something that we tried to do to get the efficiency down on the air conditioning. And there's been a whole bunch of studies on blowing air directly on your body, like from the back and the back of your neck, that cools the body more effectively than air blowing on you. So we've tried the cooled seats. They seem to be okay. It's kind of a weird feeling. I think kind of like your bum get real cold, but way less power than blowing cold air out the vents kind of thing. So we are looking at that, yeah. So to close the doors, you reach up and there's a strap. You just kind of reach up like this and pull it down. The door only weighs 40 pounds. So it's a very lightweight door. And
Whoa.
so it's and then opening up in a tight space as well. The door doesn't open any wider than the wheel skirt. So you're never going to get in a situation where you can't open your door. And it doesn't open much higher. It's like the Model Y with the Model Y and Model, which is the Tesla with the crazy back door. That one is similar to that one, where it doesn't actually create much vertical room above the vehicle.
That's the Model X.
X, yeah, with the Falcon doors. That's right. Those marvelous pieces of engineering. Did you already tell the charging ports on rate of? Yeah, so the charging ports, we're in a position now where we're actually moving the charging port from the back of the car to the front of the car. So before we had it under the license plate, which we were pretty sure was illegal. I'm pretty sure it's illegal to hide your license plate at any point. So we kind of abandoned that, and we went, and again, to move some of the components up front, the charger and stuff. The port is going to be on the panel that's where the logo is, and that panel is actually big enough to house 4 different charging plugs. So we don't know if we're going to do that yet, but we could. Pricing is in the 28, 29 to begin, and then up to like 48 for the big one, for the high-end one. The rate of charge, I don't know the numbers exactly yet because we're still working with vendors on different charges. But like I said before, what you get per mile on a 20-minute charge is going to be 4 to 6 times for us what you get in a regular EV for the same amount of time, just because the efficiency of the power transferred. Like you transfer the same amount of power, but we use much less of it, right? So you get more range from the time that you're charging.
So I got another question on the charger. I mean, are you thinking of licensing the Tesla charger?
I don't know. Those guys, Elon said a while back that he's not interested in 3-wheelers, right? Like he doesn't think they're a viable thing. So I think he wrote us off before we even had a chance to talk to him. But as far as I know, there hasn't been any. And that's locked down pretty tight, right? Like you can't just go ahead and use it. So we have to, But who knows? Who knows? It's our favorite plug. It's our favorite type of charger. That's great. How does it handle in heavy winds? I mentioned this before, but it actually doesn't. It's aerodynamic in every direction, so it actually doesn't have any effect from crosswinds. Like if a semi truck goes past you, you don't feel it. Like you just don't feel anything. Yeah, and with the weight on the tires too. Again, with these wheel motors, you get an interesting thing where you don't like the loads on the vehicle aren't being taken through the suspension. Like the weight is on the wheel. So when there's any load applied to the vehicle, you got a much more direct kind of contact patch than on a regular vehicle, or you're not going through the suspension to the contact patch, like you got weight on the contact patch. So it handles differently than a regular vehicle. ABS, yep, ABS, absolutely. And in fact, through the software, we've got like the craziest ABS. Like we've got all sorts of torque vectoring and all sorts of whatever you want to do. And on ice, it should be great. Like, of course, any car is going to be slippy on ice, right? But as far as like a vehicle control standpoint, like what we can actually do with the vehicle, like we can place it exactly where we want it, because we don't actually we've not only got like rotational control, we've got positional control on the motors. So we can turn it, right? Like we've got resolution, we've got 1,000 degrees resolution per revolution. So we can just literally place the vehicle wherever we want. Depends what charging network like Tesla has built. It'd be nice, eh? That's big money stuff, though. So I think we're just looking to plug into the regular networks at this point. Can you drift the Aptera? Yep. Like I say, with the motors, we've got drift mode. We've got whatever you want to do. I mean, the Lamborghinis, how they put you at 20 degrees in the corner and go, you got a 20-degree drift to the corner through the electronics. Like we can do all that kind of stuff too. I used to look into at APA and even with UV with the HVAC. HEPA as far as like a cabin filter, you mean? Like kind of like the Tesla has from the. Yeah, that's a great idea. Hey, I love that one. Yeah, I hope we can do that one. And even UV, like putting UV. Oh, that's an interesting idea. Is anybody doing that now? Are you using UV in the HVAC system? I haven't heard anybody doing that. It's a cool idea though. 0 to 60 is sub 3 seconds at this point. So it's quick. Yeah, no,
Nathan, I wanted to throw in that some people have been doing UV in buildings where they have it up above everybody because you don't want it shining on anyone's skin. But in the early days of COVID, they were talking about using it to make buildings safer to be inside.
And they use it in water treatment, right? I know they do it with water treatment plants. Break-in efficiency. That's an interesting one because we, so to qualify as like a vehicle and to pass all the standards and stuff, you have to have, so the laws haven't caught up yet with where regenerative braking is going and what it can do. So the laws still require you to have your dumb brakes be able to stop the vehicle in a certain amount of time. So by law, we have to have more brakes than we need, which is really annoying because there's more weight than we need. But we're basically using the regen for most braking. Like I said before, the regen is you don't get full regen in a passenger vehicle because it gets scary aggressive, right? Like you can lock the wheels up kind of thing. So we're using regen as much as we can. And because we've got lean wheel motors and we've got such control of the wheels, we can get much higher fidelity in the ABS system and on the regen system. So we can capture more energy, but we can use less brakes, right? I mean, that's one of the beautiful things about electric vehicles is you don't wear the brake pads out, right? So what speed will the Aptera be most efficient? The faster you go, the more efficient it is. What we haven't done yet is a top speed run. Actually, that would be something to do, to see how she feels at like 200 miles an hour kind of thing. It should be absolutely stable. With all sunny days, how long would it take to go coast to coast after solar? You only get about 45, 50 miles a day on the solar panel. So divide the distance of the country by 50 days, and that's how many days it would take you. 0 to 60 under 2 seconds, yep. Nice. And does the Bolt have the pedal where you let off and you get the regen and you get the gas too? I know some cars are using that technology now.
Yeah, if you put the Bolt in the L, there's pretty aggressive regen when you take your foot off the pedal. It's kind of like driving a stick manual car. And then also it's got a paddle on the wheel. So if you want a little bit more aggressive for panic stops, you can use that. Like I say, the only time I use the brake pedal is when I'm at a stop. So if someone rear ends me, I don't jump out into the intersection.
Yeah. That's nice. That's nice. Yeah. So like when I worked on a car called the Volvo 3CC back in the early 2000s. That was kind of an interesting vehicle, but on that one we had the gas pedal that was 75% gas and then 25% regen, but it was proportional, right? So you could actually like slow the car down proportionally, and it was a delight to drive. So I know a few cars are doing that now, where it's actually proportional. If you let your foot off, it's not just like regen comes on. You can actually like dial it, right? So you can actually like brake your car controllably using the gas pedal, which is a really, really nice way to drive.
Yeah, absolutely. That's the way the Bolt is. You can have the pedal wherever in low, and it does exactly what you want it to do.
And it feels like how it should be, right? I mean, you got control with one pedal. Anything to discuss on the microcooling type? The microcooling stuff is aircraft technology. It's straight out of the aircraft industry. It's just a radiator behind the skin and then a micro abrasion, like a film on the skin, just to increase the surface area, and then a bit of thermal paste, and you get skin cooling. It's expensive. That's the only thing, right? Like this, it's quite a complex little system with channels in the composite. So it's much more expensive than a regular radiator, right? But if we opened up any kind of radiator opening, we'd double the drag of the vehicle, right? With like even a little thing under the vehicle to let some air in, we'd essentially be doubling the drag. So we took the price hit and we kept the aerodynamics, and we're doing the skin cooling. But yeah, no, it's all standard aircraft kind of stuff. I think so. Again, the question about Jim about the pedal driving creep, like I think that'd be something that we should be able to open up. Like that'd be one of the things I think we should be able to give people the capacity to tune, right, and how they want to drive the vehicle. And again, because we're not a car, we have some liberties here, right? Like we're trying to make it as safe as car, obviously we're trying to meet auto standards, but it does give us more freedom of what we can do on the technology side, right? So we're not as restricted as a regular car. So we might be able to do some more interesting stuff on the regen side. No heat pump to cool the battery. There is, we do have heating for the battery, but we're actually finding with the motors too, we're not actually generating enough heat to really warrant like the cooling being really used too much. Like we're only generating 10% of what the cooling system can do on the motors, and we don't seem to be getting any hotter than that. So, and the batteries are staying really nice and cool as well. Like nothing's really working too hard. So, we're not moving 5,000 or 6,000 pounds down the road here. So everything's kind of has a breezy time of getting those electrons around. But yeah, no, the heat doesn't seem to be an issue. We've tested in hot climates. Oh yeah. In fact, the very first car that we built, we took out to Death Valley and tested in high temperatures. You got to be careful with the composites. Obviously, like we're, with composite material, it's you get into a really hot day and you got a black car, you're going to be getting close to the glass transition temperature, right? So we do have high temperature resins, and we got different things in the resins we do to keep that safe. But it's that's definitely something that we concern for composite vehicles. That's why you don't see black composite aircraft; they're all white, right? Because you have to watch the heat. I need to warm the batteries and cold. We'll probably need some temperature control on the batteries. So we got a liquid cooling and liquid heating in the batteries, like a standard stuff. Nice white one, nice. Yeah, and there's a question earlier too about paints and paint films, and I think I mentioned that we're only doing paint films, so easy enough to change your colors or modify your vehicle. Will it float? Yes, it will. Yeah, absolutely will. Even with the doors open, it'll still float. Like the structure itself is inherently boat-like, and would float. Yeah. In fact, with that smooth belly, if you enter the water fast enough, you'd probably skip along for a while before you stopped as well. In fact, you probably would actually drive in the water. Anyway, so I know that's the thing. Electric motors don't care. You can fill an electric motor with water; it doesn't care. It's only if you get into the electronics it really cares. That's a nice one. Actually, what I was messing around the other week with on the back of the car, we've got the skirt, we've got a little piece on the back that's a bumper. So if you get an impact, it's just a little foam piece. And I was playing around the idea of making that like an active trim tab kind of thing, like an airplane. But I was shut down on that one. USS Aptera. Nice. Nice. This is a fun group. How many are we doing for time? Like, how much longer are we supposed to go on for here?
Well, we, as long as you can hold up and they keep asking questions, we can, go longer, or if you have some time restraints, why we can
Let's do another 15 minutes.
Accommodate that too.
I do have to get back to work here. We've got the car to design. Changing a flat tire. The flat tire is a fun one. The car doesn't weigh much. I mean, like 2 guys can lift up the back of the car. So we've got standard kind of jacking points and very simple like quarter turn fasteners to get the panels off. So quarter turns, panels come off, jack goes underneath, and then you just put the panels back on with the quarter turns. So it should be fairly straightforward. No spare. No, we didn't even have a run flat actually, and actually that's something we should probably think about. Because thank you for that. We'll bring that up at the meeting tomorrow. Spare tire. Yeah. I think that's the thing, is the compressor and the goo, but
I like the question.
In-wheel motors, but no flat changing issues. No, that's the crazy thing about them. Basically, if the wheel motor is almost like a drum brake on an old vehicle, right? It's exactly kind of what it's like actually. So when you take the wheel off, there's the motor, and you take the wheel off, it's like a regular wheel. And it's even a regular wheel, like the hub bearing is a standard hub bearing. It's not anything weird. It's just a regular bearing. Financing. I don't know. Actually, I don't know about that one. I know that the whole world of financing is getting more creative at this point. And I know that there are financing companies that have approached me about helping with financing. So it's not my department, but I know that's a towing option. Or like to tow something with the vehicle? No. No towing option.
Size of your wheel, size of the tires.
It's still kind of in flux, but it's a 17-inch rim. I think it's 5 inches wide. It's standard kind of profile. It's a standard Michelin, a good Michelin and a Goodyear, standard kind of tires. We looked at doing like a BMW i3 tire or like that kind of crazy stuff, and it just became unobtainium to get them, And you want to change your tire somewhere, you just end up having to be stuck for 2 weeks waiting for something to show up. So we ixnayed all that, and we just went with the standard tire. It's a low roller resistance tire kind of thing, but it's a normal.
Well, Michelin's coming out with an EV tire in a month or so that's supposed to give even more efficiency.
Nice. Yeah, everyone's working on it. Hey, it's great. Did you guys see that Mercedes that just came out too? That they're claiming an incredible aerodynamic efficiency on? I just saw it the other day. It's a beautiful car, but they're really trying to hit the aerodynamic kind of button now. See if they can make some progress there, which is good to see as well. No loss of cargo space. All the batteries are under the floor all the time. From a weight perspective, you have to keep the batteries down and forwards. So, but this kind of thing too, like I said, this seems like an outrageous number now, but if you look at battery technology, like 5 years from now, this is going to be, it'll be irrelevant. It'll be, this will be normal. It's really changing quickly. Minimize the CFD, exactly. Well, it's actually really interesting. The CED side of things is fascinating. That's, we've had some amazing people through the years help us on the CFD calculations, and the team we've got now are just remarkable. But when you normally throw something in a computer, sort of like a CFD program, you see all these issues and see all this big mess and turbulences and all these different things, eddies coming off. And when you throw the Aptera in there, you see like a picture of an airfoil going through like a CFD, like it separates and then it reattaches at the back. So the results you get are just beautiful. Like they're having so much fun, and the aerodynamicist guys are like, finally, something that's aerodynamic that we get to work with, instead of something that's non-aerodynamic that we're trying to fix. So the simulations we get are just like they're beautiful. And that software now, the simulation software, is becoming to the point where, if you guys know about generative design, which is a type of software where you just put a basic volume in with loads, and the computer calculates the structure of the part for you. Right, so it calculates the strongest part possible with the minimum amount of material, and a computer can do orders of magnitude more than a human can do as far as efficiency and iterations to a design and coming up with like the most efficient design. So the generative design software is now being applied to computer dynamics. So you can actually create like a boundary layer and then have the computer define which is the most aerodynamic path through that boundary layer and then give you that result. So like the software side of things now is just absolutely mind-blowing what we can achieve. It's quite crazy. Can pick them San Diego rather than delivery. Nice. I think Sarah, who's our main like marketing lady, she's up for any and all ideas about delivery and having fun with that. And now we get people their cars and going to the factory and stuff. I mean, it's I think basically whatever you want to do in that side of things. I mean, even visiting the factory. Like I had friends in the past that bought a BMW and they went to Germany and saw the car being built and then drove it back, kind of thing. I thought, what a beautiful thing to do. Like that's a nice thing to do. So it'd be nice to get into that kind of thing. Factory tours, yeah. I don't see why not. I mean, like it's a non-hazardous work environment, right? So we don't really have to worry too much about welding and paint and all that kind of stuff. So it should be fairly accessible to everybody. Do you guys have any other ideas? Like I always like enjoying using these kind of things to try and get some good feedback. So as we kind of wrap this up, is there any crazy ideas anyone's had, or any interesting kind of thoughts, kind of thing that we can maybe take back to the team with?
No, I'll just say this. You already did one of my ideas, in-wheel motors.
That's a good one. We'll take that one. Thank you.
Well, Nathan, how about having the rear tire exude a biodegradable lubricant so you can spin on the dime?
Did you see that? There was actually a GM car back in the 50s, I think, for snow. You had a little thing in the wheel arch. You would spray some kind of lubricant on the tire so you get better traction in the ice. It was like a real thing. Like back in the 50s, I think it was a Chrysler thing. So we probably don't want to like decrease the the friction. We want to try to increase the friction. But
Well, it's only for parking when you want to spin on a dime. One front wheel runs forward, one runs backwards.
we can actually crab the vehicle like a bobcat with that much power standing still. We can literally just tank it. Like we can just crank the one side and it'll just tank around.
So the rear wheel just slides sideways.
Slides, yeah. Oh yeah. The front wheels just pull it like no problem. Yeah. So you could do all sorts of things with that one, yeah. Four-wheel vehicle, yes, we are considering a four-wheel vehicle. And then I've heard talk about like a truck and all sorts of other things after that. So, the kind of overall concept here is that, everyone's missing the boat on lightweighting and aerodynamics. Everyone's kind of just completely missed the opportunity there. So we see opportunities to do all sorts of vehicles using the same philosophies and getting the same gains in efficiency, right? I mean, why not?
Well, a lot of Americans are terrified of the idea of being in a lightweight vehicle because when it gets stuck between a couple of trucks, they can't imagine it being kicked out of the way like a soccer ball.
Yeah. Well, that's what we're trying to fix with this whole notion that a lightweight vehicle means it's less safe than a regular vehicle, right? Like, which isn't the case. It just depends on the materials you use. Like, if you made a vehicle out of cobalt, right, it'd be tremendously stronger. You know what I mean? So it's like, you just pick your material, right? And and actually when we did the first car, we actually designed the front subframe to shear on an impact. So we had it at 45 degrees so that the vehicle would go up and then the main mass of the vehicle would stay and you'd actually separate and go flying up and remove yourself from the accident scene, right? Just get yourself the hell out of there and off you go skipping down the road in your little toboggan afterwards, right? But we scrapped that idea. It wasn't going to work. But no, it would, when we actually get to the point where we're like destroying vehicles again, and we can release those videos, people are going to be amazed, how well it performs. It's like you throw it off a building and it'll just bounce. You throw a 10-story building, it will just go boing, 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 and that'll be it, right? A great tailgating vehicle, no, because you wouldn't get any pull from the vehicle in front of you. You would barely get anything. The cargo space is actually an interesting one because we're working on a design now where we have a bit of space behind the passenger compartment where we actually can have like a lower storage. Panels in the floor that open up because we've got some space down there. We wouldn't want to add anything heavy there. Tailgating at a football game, yes. Actually would. That should be fantastic for them. But if we had a smaller battery, we actually have more space under the floor now, so maybe that could be used for cargo, that kind of stuff. Personally for me, I don't drive very far. Like a little battery, like a quarter of the size of the big battery would do me. Right, which is basically it's only like a battery about 2 feet long and the width of the vehicle, and you'd have all sorts of space under the vehicle if you did that. 3-passenger version, like the McLaren F1. I wish, man. No, I don't think so. No, it's not. It's the body's not that wide. Although that is my favorite car of all time. So if I could have a 3-passenger, I would. A lake sailing option package. Nice. We're going to have to take one in the bloody water now. Oh my goodness, that's crazy. Did you guys see, I don't know if you know this, but the first Aptera, if you guys any Star Wars, Star Trek buffs out there, the Star Trek movie that came out, the first one of the new series, the Aptera was actually in that movie, in the university scene where they go back to school. And in the background, the car drives by in the background. They approached us to put it in the film the first time, so that was one of our cool moments on the first round. Yeah, that one, yeah, the Star Trek, yeah. We got some great pictures. So we got pictures from when we took it to the White House the first time. We actually campaigned, and I believe we won. I think a few of the companies won to try and increase the weight of a motorcycle so that we could be classified as a motorcycle. And we took it to the White House before, and there's some great pictures there too. Possible backrest in the back. I think the backpack storage is still there. Yeah. There's some other ideas now. Jason Hill, who's our kind of like main designer guy, who's incredible. He's got all sorts of fun ideas for the interior, especially like on the camping side of things. And anyway, there's gonna be lots of fun stuff. And it's going for like a real like wetsuit fabric style interior that's like wash downable and really durable and stuff. I don't know if the credit got approved yet. I think that's something else that we're actually working on as well. Yeah. So we got the lake sailing option package out of this. We got the spare time. What do you guys? The question to you guys too: how do you feel about vehicle to grid technologies? Like how? Like, do you guys feel there's any like relevance in North America for V2G or any use for it, kind of thing? Or? Oh, Jeffrey, you're on mute, man. I think you had a good point there.
No, I'm just saying, bring it. Well, I'm trying to use hand gestures, but I'm saying, bring it, man. Get the V2G. We want that stuff.
Here in California, we have all these PG&E power shutoffs to avoid fires, which we get anyways. And vehicle to grid would be very handy to get people through sometimes 3-4 day power outages.
Which you would be able to get, right? You'd get 2-3 days easy with the battery pack and this kind of thing. No, I know, right? It seems like a no-brainer to me, and the technology is definitely coming along. One of the things that we're actually looking at now, though, is how so V2G is fairly simple, but V2G with load balancing of the grid is the next step, right? And we did a study here in Calgary a couple of years back where I don't know if you guys know the whole like system of the power grids, but how like these massive power stations they run to feed the peak current of the grid load. Right. So like at 5 o'clock in the evening, everyone comes home, turns on the ovens, TVs, you get this massive peak load. 8 o'clock in the morning, everyone gets up, switches on the toasters, you get this massive peak load. And then it goes down again, then it goes up again, then it goes down again. Well, the power stations have to run to maintain the peak load. And you can't turn them up and down that quickly. It takes 2 or 3 days to turn down the power output of a coal plant. So all the power stations have to run at this peak load. And then all the energy that they don't use in these down areas, they should basically just give away. Like in Alberta here, we give away all the energy to BC at night that we don't use, that we create. So there's this massive inefficiency in the system. So we did a study, and if you had vehicle to grid and you were able to use the vehicles to load balance the grid, you would only need 10,000 vehicles plugged into a city of 1 million people to give enough load balancing to take those peaks and chop them right off. That like 30% of overpower disappears. And that's 10,000 vehicles in a population of 1 million. Is enough battery capacity to remove those peaks of the power. That is crazy, because that's huge emissions, right? Being able to cut our power by 30% on the power stations, like right now, with 10,000 EVs plugged into the grid with load balancing technology, right? That's like, that's fantastic. So how do we get there, right? And I mean, it's a huge conversation between the power utility companies and electric vehicle companies, and how we create a common language so everything can talk. But it's got to happen, right? Like V2G seems like a no-brainer, but grid balancing has got to happen too.
Well, Nathan, the CCS charging, DC fast charging standard within 3 to 8 years is supposed to have vehicle to grid, which would enable that. And a lot of the manufacturers apparently are saying they will not put software patches on their older gear, their older cars, in order to make it work with the new standard. But it's just software, because the contactors are there to have access from the traction battery to the DC fast charging port. And then it's all the external equipment that syncs it with the grid and charges or discharges. So the equipment's there in DC fast charging cars, but it's just not accessible with CCS. But it is accessible with the Japanese CHAdeMO, but it's not approved for use in the US CHAdeMO. It may never be, we'll see.
Yeah, but the one other one is the Tesla, of course. Yeah, well, we've looked through them and have a Wheatstone bridge or something on their charging system. So the jury is still out if they support vehicle to grid. We don't know yet.
That's interesting. That's interesting. So I think vehicle to grid for sure, but load balancing, that's interesting. Yeah, doing it through the chargers makes sense. That's a good idea. Yeah.
Right, and that's what I was going to say was at least make your car bidirectional on the inverters. So at least you could go the other direction, because that is the easiest way, synchronizing with the grid frequency. I'm sure this is a whole bunch of technical issues to do that. So maybe all you do is provide the power, and the person who wants it may have to buy a separate box at their house that does that syncing to frequency and islanding your house and all that type of stuff. Is probably beyond the car. You don't want to build in too much to your car, but at least allow it to go a bidirectional inverter.
Well, for sure. I mean, having it power your house is a no-brainer, right? If you have a power outage, so that kind of stuff shouldn't even be a point of discussion. But the load balancing stuff is really interesting. It's the same as if you bring a solar farm online or a wind farm online. right? You have to put that into the grid somehow, and it's all got to get balanced. And it's all 100-year-old technology, right? Like the grid is still pretty antiquated. So, but I get the sense it's coming along quickly, right? And the smartness and the intelligence in the grid will start improving. We'll start seeing some, but electric vehicles are going to have a massive part of that. That's called, someone mentioned AC propulsion on their cars, on the Mini E and the T0. So AC propulsion, I don't know if you guys know those guys. They're a big part of the whole EV story. They came out of the EV1 program when it closed down, and they basically kept the technology going. And that was a technology that we ended up putting in the Volvo 3CC, which ended up being used in the Teslas. So there's a whole lineage through AC propulsion being kind of like a cornerstone of the whole EV industry. And Alan Cocconi, who that's what AC stands for, he is an absolute madman, genius guy. Basically invented like the modern motor controllers and like the style motors in the Teslas with a very, very thin air gap between the rotor and stator. That was all his work. They're an incredible company.
Nathan, I just wanted to add with the vehicle to grid that a number of the manufacturers are putting in just a single outlet for vehicle to load, either the pickup trucks so you can run power tools, or some of the other cars so you can just plug in, like, run an extension cord to the house and run your fridge and a couple of lights in case of a power outage, or if you're camping.
Yeah, well, that's just an inverter, right? There's nothing to do that. But you're having a bit more efficiency through that system, so you don't get the loss of a crappy inverter, right? Changing that to 120, that'd be good. And the Cybertruck too, yeah. Michael having a nap. Proximity alert for wheels. That's a good idea. That's a good idea, actually. Yeah. That's a good idea.
Will it purr at low speeds so pedestrians can hear it?
Oh, that's silly, eh? That silly rule about noises. Everyone's having fun with different noises too. Porsche's got one now. You heard that one? It's like whoop, 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 kind of a noise. It's really weird.
Well, I will say I drove Leafs. I drove Leafs before I drove a Tesla, and man, I missed it when I went to the Tesla. I love that beep, beep, beep backing up sound. I missed it.
Metal in the frame, we've got steel and aluminum. Yep, a lot of hollow tubing, that kind of stuff. The suspensions, the front suspension's aluminum, the front subframe is aluminum, the rear subframe is aluminum, the rear swing arm is steel. So a bit of everything in there. Jetson knows what the best. I saw a guy who put an MP3 player in his car, like he loads sound clips into whatever his car did. So when he opened the door or whatever, it just made whatever noise he wanted to, and it was a lot of fun. So yeah, I don't see why we couldn't do that. And again, it's all so simple, right? That's like an Arduino. That's a $5 microprocessor to do all that kind of stuff. Data's takeoff. That'd be a good one, hey? The data sound. What's the sound for? Time and relative distance in space. Is that what it is? Noise apps will be good.
Yeah, it's time and relative dimensions in space. Or dimension. There's one dimension in space. There you are.
Thank you, Jeffrey. Appreciate that. Yeah, those kind of apps. I mean, Tesla really, I think, did a great job with their with the fun that they had with the interface, right? And the plaid mode and the ludicrous mode, and just having fun with it. And that thing recently about open your butthole, like that was crazy, right? And then I think it was Jason Tolchinsky on Jalopnik is like, well, who said that first? Why did they say it? But it's great they're having fun with it, like they're really just making it and I think that's probably the big appeal of the brand is like they're not taking it too seriously.
I mean, they've got the more cowbell thing. You can have your Tesla play that, or there's a secret Monty Python thing. It's all built in there. Yeah.
No way. Like the Christopher Walken Need More Cowbell skit is in there.
That's it. It's right in there.
My goodness. Oh my goodness. Yeah, the LiDAR thing's interesting, hey? All right, pedestrian sound. Tesla fart sound. Oh, this is great stuff. Can we sort of wrap it up there? I kind of do have to get back to work here. I'm having a blast, but I do have to get back to work. Yeah, hold its value. Yeah, for sure. And again, like we are designing it to last indefinitely, right? That is like with a composite monocoque, if it doesn't get impacted, it's never going to rust. It's never going to anything happen to it. So we really hope that these vehicles last a long time and become a real nice legacy kind of piece. So
Okay, well, I'll bring this to an end. Thank you very much, Nathan. I wanted to say a few things. First of all, I'm a reservation holder, and you can go on their website and reserve for, I think, $100. And I think somebody early in the chat gave their referral link where I think you get like $30 off the reservation. Yeah, so thank you very much. This was really interesting.
Awesome. Well, thank you, everybody, and have a great evening and have a great weekend. I guess we'll probably talk to you next time.
All right.
Thank you.
Thanks for coming, Nathan. We're glad to have your input on this, and it was very informative. A lot of questions, so there's a lot of interest. And one thing I might tell you, you might be able to take back to the team. Back in the late 70s, early 80s, I'd have to go back and research through my electric vehicle news magazines, but there was a car that was called I think they called it a sail car or something, but it had a aerodynamic arch that was like in the back of the vehicle. And when you got in the right position, the wind would actually help carry it just like it would be a sail. There was some things picked up that way, but that may be a little far-fetched, but if there's any interest at all, I can search that out and at least, find out what it was and where it was and all that sort of thing. But it looked really neat to have this arch over the car that was aerodynamic arch for the wind sail. Another thing I might mention too is there was a question in reference to the EV tax or the gas tax. There's going to be some changes and stuff. Just 2 days ago, the state of Colorado in their legislature introduced Senate Bill 21-260. And that is a fairly comprehensive bill. It's 200 pages long. And all of the things that the state of Colorado is going to be doing and how they're going to add a little bit to the gas tax over the few years, how they're going to be adding a little bit to the electric vehicle fee and all that kind of stuff. But you can go to leg.colorado.gov and you can put in that SB 21-260 and you can see a lot of the ideas that they're coming up with in forward thinking as to what they're going to be doing over the next decade. And we had a presentation from the executive director of the Colorado Energy Office, gave us some information on that today on a group in the policy group of the Colorado Electric Vehicle Coalition. So that was kind of interesting.
Cool.
That's where we're going to be kind of going in the future to kind of offset the EVs as they come on board and stuff. But it's a lot of change is going to take place over the next 10 years for sure.
Interesting to see what they talk about grid-wise too, because everyone's saying that like without the EVs coming on board, the grid's going to have challenges, right? So interesting to see what they're thinking about from a grid side too. And Colorado being one of the most progressive places on the planet, I'm going to read that because that would be some pretty good stuff. So thank you, David. I appreciate that.
Yeah. So it's some interesting info there on what they're going to be doing. It all has to go through the committees and pass both the House and the Senate and the House before it actually is made law, but there are some ideas in there anyway.
Fantastic. Well, thank you. Appreciate that. Awesome. Great. Well, thanks everyone.
All right. Thanks, Nathan.
We'll talk to you soon. Bye.
I think we'll just go ahead and wrap this up for the evening. I'm glad everybody showed up that did. And we may have another one of these on almost the spur of the moment events later on, but we do have a vehicle to grid or vehicle to building meeting coming up on Saturday, I believe it's the 15th, isn't it, Julia?
Yeah, the 15th at 10 o'clock. So there's a nonprofit called the Alliance Center that is actually doing an experiment on vehicle to building in their case. So if you're interested in that topic, May 15th at 10 o'clock.
Okie doke. Well, thanks everybody.
All right, so this is the end of part 2. Wow, really cool information. Hope you guys enjoyed it. And again, if you want to watch part 1, if for whatever reason you chose to watch part 2 first, there should be a link in the description below so you can catch part 1. Thanks for watching, and I'll see everybody next time.